Threadripper 7000 is launching, film at 11. Threadripper 7000 high-end desktop edition, 4 memory channels, ASUS Sage TRX 50 motherboards. That's what's in this video. There's more, there's so much more, but this is what we're going to get started with. First up, if you've been living under a rock, Threadripper 7000 series is back, and Threadripper is back with a vengeance. A lot of people said, hey, Threadripper Pro is great and all, but we've sort of been priced out of buying Threadripper Pro because everybody is buying Threadripper Pro for their workstations. Creative workloads, making movies, whatever you want to do. 64 cores, 32 cores, and AMD said, okay, that's cool. So there's Threadripper Pro again, 7000 series, 96 cores this time around. But this video is about TRX 50 and high-end desktop, 4 memory channels, a Threadripper CPU in a new socket with DDR5 memory, registered error-correcting DDR5, even on a high-end desktop platform. A new ATX-ish motherboard, lots of PCIe Gen 5 connectivity, lots of M.2 connectivity, and even dual power supplies on our Sage TRX 50 motherboard from ASUS. Let's take a closer look. So the new platform, the first thing that we should talk about is memory. It's DDR5. It's registered error-correcting DDR5. That means that you're going to have full support for 256 gigabyte DIMMs, LR DIMMs, 3D stacked DIMMs, RDIMMs, registered error correcting memory. That's what we're talking about. This is the memory that is normally used in servers, and this memory is brought up and qualified well before desktop DDR5. In going with this platform, AMD is able to sort of sidestep a lot of the DDR5 teething issues that we had. And that, even though it's server memory, is still overclockable. And it's 5200 support out of the box, which is weird because 5600 is what's actually a thing. There's not 5200 as far as I know, but I'm running 6400 without issues. So I just plug and play. There's some things we should talk about with memory though. Throughout the history of x86, it's often the case that AMD does something first, and then Intel comes later and does the same thing, but the benefits from the industry experience from having done the thing with AMD, motherboard makers, memory vendors, etc., benefit Intel because AMD did the trailblazing. AMD figures it out, and everyone else, including Intel, benefits and refines from the approach that AMD figured out, and it becomes the norm. In this case, though, with DDR5 and workstations, it's a bit of a role reversal, and that's proving to be a huge benefit for AMD, I think. This time around, Intel beat AMD to the punch with their overclockable workstation registered error-correcting memory. Overclockable registered error-correcting memory? Yeah, that was bringing up the DDR5 platform. On this, our G-Skill memory kit, these are RDIMMs, registered error-correcting memory. This is not normal desktop memory. This is the type of memory that you find in a server, except it's got an Expo profile. It's got an XMP profile. It's overclockable. It can run at DDR5 6400. I mean, in a lot of ways, it really has worked out to be a huge benefit for AMD, at least in terms of cost management and production and being able to tweak things and build new stuff. But memory latency was not one of those benefits. It made the memory latency a bit worse. Effectively, the memory is a bit farther away from the CPU, and large caches and clever design and that sort of thing can make up for that. And so dog determinism made the AMD team work on massive caches and other technologies. 3D V-cache put them far ahead, so they made up for it. Gaming, of course, is one of the things that benefits from the lowest latency platform possible, and having more cache is a bit like lowering the latency because more of the stuff can be cached near the CPU. It's like as if you sped up memory without actually speeding up memory because stuff's closer. But there are non-gaming workloads that benefit too. Usually, it's been the case that desktop memory can be tuned for the highest throughput and lowest latency, and that's certainly been the case on Intel's desktop platform like Z690 and Z790. Boy, howdy, the memory there is fast. However, it's very much not the case on systems like our ASUS Ace W790 or even our Falcon Northwest W790 system behind us, which is based around the ASUS Sage. Now, I'm still salty about Intel doing a rug pull all the way back on the i9 Extreme 7980XE that launched with registered ECC memory support and ECC memory and unregistered ECC memory, but then later via a microcode update on that X299 platform, they disabled support for registered error-correcting memory versus their desktop counterparts. And so even digging back as far as you want to go there, the X299 platform supporting all three of those, the memory latency wasn't really that great. enter Threadripper Pro. Threadripper Pro also supports all three of the DDR4 variants. It was a little tough for AMD to deal with that, but generally pretty good. And apples to apples, unregistered, gaming memory versus registered error-correcting DDR4 memory. That registered error-correcting DDR4 memory, even clock for clock, is going to be a little slower. It's a little harder to qualify. But here that doesn't seem to be the case. At least testing W790 versus the new Threadripper high-end desktop platform. All of my Sapphire Rapid systems are around 100 nanoseconds. But check this out. NPS 4 and the new Threadripper HEDT platform is able to achieve 60 to 70 nanoseconds in just 4 memory channels. Look, I was not expecting the memory latency to be anywhere this far under 100 nanoseconds, because it's even 100 nanoseconds on servers. 60 nanoseconds on a registered ECC platform, high-end desktop Threadripper? All I can say is congratulations to the AMD engineering team. This is an accomplishment and a half. It's not often that I say that these results are so good. I didn't believe them. There's got to be a bug with AIDA64, and yeah, AIDA64, take it with a grain of salt, but this is replicable across a bunch of other things. These results are going to be great for gaming, regular workloads, everything else. 68, 70 nanoseconds. These results being so good, I think also eliminates one of the reasons for not wanting to go with registered ECC memory for high-end desktop, and that is, the memory is going to be faster if you don't use registered. But this speed result is quite good for registered error-correcting memory. This is rivaling or on par with DDR5 memory speeds on just regular old desktop. And you throw in the benefits of it's a lot easier to turn on and bring up, and you don't have the training issues, and you get 4 channels, and you can have really insane densities like 256 gigabytes per DIMM for a total of a terabyte. There's, registered error correcting memory was absolutely the right move, even for high-end desktop. And these memory results are incredible. Okay. Another thing that you should be aware of is when you move from 4800 to 5600, your memory produces a lot more heat. DDR5 memory, in my experience, doesn't like to run past about 60 degrees C. You can have a much more stable system at less than 60 degrees C. There are actually some tunables and some stuff that runs under the hood that will cause the memory to self-throttle so that you don't get errors, but it just doesn't run as quickly as it should. And things are a little crowded on our Asus motherboard here, and it does perform a little bit better if you make sure that your DDR5 DIMMs are in all the way. You can be off by fractions of a millimeter, so you got to be super careful installing your memory. If you have weird, mysterious issues, just rearrange the order that your memory is in, make sure that it's good and stable. Double check that your front side bus speed is what it says it is. When I was playing it a little fast and loose with the memory here, I was getting weird things like 95 megahertz front side bus speed because I think of an excessively long memory training. But that's neither here nor there. 6400, stable, and 300 gigabytes per second memory transfer, as reported by AIDA64, is phenomenal. Just by way of comparison, if you look at the Asus Ace platform for W790 with the 24-core Sapphire Rapids X-Series workstation part with an overclock, DDR5 6000, we're still only managing to do about 120 to 130 gigabytes per second, as reported by AIDA64. Yes, granted, AIDA64, take those numbers with a little bit of a grain of salt, but just shy of 300 gigabytes per second on our same 4-channel configuration, but this time on the AMD platform. How did they do it? I don't know. Wizardry? Black magic? Unholy sacrifice? We'll never know. This time around, Intel beat AMD to the punch with their overclockable workstation registered error correcting memory. Overclockable registered error correcting memory? Yeah, that was bringing up the DDR5 platform. On this, our G-Skill memory kit, these are RDIMMs, registered error correcting memory. This is not normal desktop memory. This is the type of memory that you find in a server, except it's got an Expo profile, it's got an XMP profile, it's overclockable, it can run at DDR5 6400. The 2 CPUs that I have to test are the 64-core and 32-core variety. So 64 cores and 32 cores. For DevOps and software developers and stuff like that, 32 cores is going to be your sweet spot. You get all that I/O, all that performance, and the memory capacity. Yeah, you can just run everything from RAM. Node.js, web development. Oh, Lord help you if you're doing web development. All that is going to run like greased lightning on the 32-core platform. If you're doing creative stuff, making movies, rendering, a whole bunch of stuff like that, then the 64-core may be more to your liking because, gosh darn it, it does a lot. And you may be thinking, 64 cores with 4 memory channels, isn't that going to put a fair bit of memory pressure on things? And the answer is, yeah, it does. It depends on what you're doing as to whether or not you're going to bump up against those limits. But you've got somewhere to go. You can go to the 8-channel Threadripper Pro platform. But generally, for the kinds of stuff that I was doing, 4 memory channels was fine. And I think that's partly because 300 gigabytes per second with just those 4 memory channels. I mean, over 100 FPS in Cyberpunk 2077, that's not really that big of a deal, right? But I'm also running OBS and Handbrake encoding, and I'm also recording a bunch of other stuff. So there's like a billion background processes. That's what we're doing with 64 cores. And you don't even know any of that insanity is going on in the background while you're playing a game. It's madness. This is the slow preset. Yeah, so even though games don't necessarily use the 64 cores, you can find stuff to do with 64 cores even while you're gaming, and it never gets old. It's like, oh, I'm playing a game and I'm running at 110 FPS instead of 150. Oh, it's because I had all of my other cores pegged. That's a very liberating feeling, let me tell you. Windows is still a little bit on the struggle bus with 64 cores and 128 threads. I shudder to think what the 96 core is going to do. By way of comparison with our 56-core Sapphire Rapids Intel monster, that's our Falcon Northwest system. Here we go, moment of truth. Our 56-core Intel Sapphire Rapids platform and our Falcon Northwest workstation. Falcon Northwest will build you an awesome workstation. They did a custom one for me. Just over 1,200 watts. And still 13,000 points shy versus our Threadripper system. Yeah, the Intel Sapphire Rapids isn't there in the efficiency department. 400 less watts at the wall and 13,000 points higher for Team AMD. This is not insignificant, folks. Now, the Falcon Northwest system is amazing. It's probably the best machine learning platform that you can get out there for the Intel platform, for OpenVINO and everything else, because Intel's got all their accelerators and AMX and a whole bunch of other things. I did a video walkthrough on setting that system up for machine learning. I think I need to revisit that on the Threadripper, or possibly the Threadripper Pro platform, but that machine is no slouch, especially because it's got an overclock out of the box. At Intel defaults, understand though that 56-core Sapphire Rapids CPU is actually slower for raw compute than a 64-core 5000 series Threadripper. So, can the overclocked Falcon Northwest system touch our 64-core Threadripper? No. And a longer answer is Intel's going to be a little bit on the struggle bus here when it comes to catching up. Fortunately, they are launching Emerald Rapids CPUs, the successor to Sapphire Rapids, on December 14th, but those are server parts, not workstation. We're going to have to wait until 2024, I think, to see updated, refreshed Sapphire Rapids / Emerald Rapids workstation parts for systems like that. But here's hoping. Hey, competition. Woo! Now, I was momentarily over the moon looking through BIOS options on our Asus motherboard here. I saw options for CXL and secure encrypted virtualization and memory and all of the enterprise epic features. But the reality is that even though those options are there in BIOS, I don't think those actually enable on these CPUs. The BIOS also shows things like 12 memory channels and dual socket. We're not going to see a dual socket Threadripper. It's not going to happen. If it does happen, it would happen like more than a year out. There's not a dual socket platform imminent. That's in part because of code reuse, and in part because I think Asus needs to put a little bit more attention into their BIOS. There's also weird stuff happening in the BIOS, like momentarily it was reporting that the temperature of the CPU was like 200 degrees C. I can tell you the memory is not momentarily 200 degrees C. Those are little teething issues, and for what it's worth, this platform has had way less teething issues this time around than any other AMD platform thus far. Zen 4 Power, basically headache-free, plug and play. Yeah, I'll take it. We wanted to do a quick run through of the benchmarks for their 32 and 64 core configurations, and boy, this system does not disappoint. For Puget Bench on the Adobe Photoshop side, 166 with the 7970 and about 152 with the 7980X. That's pretty impressive. For Premiere Pro, we're looking at 133 versus 135. Going from there into 3D Mark, the 3D Mark numbers are pretty impressive and speak for themselves. You're not going to see a difference in graphics score because it's the same graphics configuration with our reference Founders Edition 4090. Blender for BMW, 35 seconds and 21 seconds versus 73 seconds and 45 seconds for the Classroom. Now, Cinebench is where it gets interesting. Out of the box configuration, a score of about 96,000. Now remember, it was just a couple of years ago that an overclocked dual socket Milan was able to hit just about 100,000 with two 64-core CPUs. And now we're in a spot where a Zen 4-core 64 cores running at stock, running with really good cooling so that we can get all of those lovely boosts, is going to do 95,000. Now, if you just toggle on PBO and let the CPU do what it thinks it wants to do, well, you're going to use 800 watts of power. It's a lot, but you get some really insane scores. I know what you're thinking. I want over 100,000 score in Cinebench. Well, you can do that with PBO. Obviously, it's very easy. But in different reviews, you're probably going to see a lot of variation in your Cinebench score, and that's going to have to do with memory. Well, actually, more precisely, more accurately, it's going to have to do with power budget and power usage on this platform. You see, this is 350 watts from on high from AMD. So you have your I/O power budget, your SoC power budget, including your memory controller, and then your cores. So running at 6400 is going to consume a significantly higher percentage of the power budget than it would at the default stock of 5200. Basically, you run your memory at 5200, the CPU can enter deeper sleep states for everything but the cores, and more of that power budget will go to the cores. The effect is that threaded workloads that don't depend on the memory controller, like Cinebench, get more power, and the score is higher. In retrospect, that explanation probably seems obvious, but that doesn't mean that, just 1,000 points difference in a Cinebench score is going to spawn page after page after page after page of armchair speculation on internet forums. But now you know. For the Threadripper Pro side of things, and for some of the fun stuff around the relaunch of Threadripper high-end desktop plus Threadripper Pro, I was able to connect with folks from ANSYS who make computational fluid dynamics and simulation software, and other folks from AMD that use this software, and they were really singing AMD's praises in terms of building workstations around these. Now, primarily they're talking about these as Threadripper Pro workstations, but I am fortunate enough that they shared some numbers for performance in terms of their workstation class products, but running on high-end desktop parts. So, for example, the 7980X and the 7970X were able to score about 2.9 to 3.0 with SolidWorks, which is a pretty amazing performance bump. Threadripper Pro, of course, it's going to be 3.5. It's going to be a little faster, so you do get what you pay for. Revit 2022, the RFO benchmark, also scored about 76 on a Threadripper Pro system versus 73.6 and 72.1 all the way down to the 7970X. So a high-end desktop, 7970 for Revit, your light hobby architecture, it could get the job done. I mean, you're still going to have registered error-correcting workstation class memory. This Asus Sage motherboard is definitely workstation class. Everything else about this build, definitely workstation class. One fun thing about this board for enthusiasts and overclockers is you can run dual power supplies. So this is very similar to what Asus did for Intel's W790 Sapphire Rapids platform, and not really a lot has changed here. If you wanted to run two 850-watt power supplies instead of buying one 1600-watt power supply, you can definitely do that, and I have done that with our Lee & Lee Dynamic 011 because that case supports dual power supplies. So it's pretty easy to connect the Asus Sage bundles cables that you need, and you really have to pay attention to which thing plugs in where because it doesn't support fault tolerance or failover. I feel like that's an oversight on Asus's part. They could have put about $3 worth of stuff in here and been able to handle power supply failover a little bit more gracefully, but you could run dual 850-watt power supplies and have 1700 watts of power and be able to run your workstation. Interestingly, depending on which power supply fails, it can survive that, but it's definitely not a recommended situation, and wasn't super amazing in my testing. But hey, could be worse. One place where AMD is behind our Sapphire Rapids Asus Ace-based platform here, this is 24 cores of pretty awesome kick-ass workstation, is NVMe RAID. So I've got a little RAID set up here, 12.9 gigabytes per second, pretty good latency, and about 327 microseconds of latency, give or take. This is VROC, and this is based on Intel's driver, and Intel's on like version 8 or so. This is actually a pretty competent platform. The licensing issues, which I'll talk about, there's an add-on that you pay for. But in terms of VROC, the technology, this is good. In case you didn't get the memo, hardware RAID is dead. This is how RAID should be approached. It's a nice wide highway into the CPU with lots and lots of PCIe lanes. So if you're rocking Gen 5 SSDs like our Kioxia CM7s, from just one CM7, you can get this kind of performance. If you have a RAID 1 or a RAID 0 or a striped mirror, you can get real-world performance in the 20, 25, 30 gigabyte per second range with those SSDs, just having 2 or 4 SSDs in your platform. But as far as I can tell, AMD hasn't done anything with their software RAID option. Oh, sure, the Asus Sage motherboard for TRX 50 does have the RAID option, and you can enable RAID mode, which does bifurcation to X4 on all of your PCIe slots. The problem is that the software kind of sucks, and the performance is really lackluster, especially when you are running high performance NVMe. If you load the driver and you do a benchmark like this, the microseconds of latency is pretty wildly inconsistent. It's basically not worth the headache of setting up, and in my experience has been a little flaky. And I'm sure that AMD would tell you that no one is using software RAID, which is why they didn't put any work into it, but hardware RAID is dead. Now, some of the Dell workstations around Threadripper Pro, they are using hardware NVMe RAID because they know there's not really an option on the Threadripper platform. But really, this is a Windows problem because VROC in this configuration here does require a license key that I was able to get on eBay for about $40. MSRP on that license key is supposed to be like $200, which is a little unpalatable in a workstation configuration. That's very much Intel snatching defeat from the jaws of victory when it comes to a competitive advantage over AMD. So that's good for AMD, I suppose. The performance on Linux is basically identical, though. So if you're running Linux on your workstation, you literally don't need a VROC key. All it really unlocks for you is NVMe remote management and a slight hardware acceleration. Intel is working on code paths that will use other features in their CPU to make VROC-based Linux MD RAID run faster. But by and large, right now, the with VROC and without VROC Linux MD code path is identical performance. And that means the performance on the AMD platform is also going to be comparable. So if you're building a Linux workstation and you want to run NVMe RAID, you're good. It's going to be great. It's awesome. But it's not because of anything built into AMD's platform. It's just because it uses the same stuff. But if you're building a Windows workstation, I really wouldn't recommend AMD's RAID drivers. It's a little bit of a chicken and egg problem. Maybe it'll be good someday, and maybe it'll be worth recommending. You can actually run VROC on Windows. Like, that's not actually terrible, and I would rather have that than the Broadcom RAID card solution. And the Broadcom RAID card solution, actually Broadcom, probably because of level 1 techs and a Bavarian normie pleb and I submitting tickets, having problems with Broadcom chipsets, they literally changed their websites to say that the Broadcom PCIe RAID card doesn't support plugging a drive directly in with a cable. It must go through a backplane. And really, this is probably Broadcom doesn't want to support end users, like end user customers. They only want to support OEMs like Dell and let Dell figure it out. But very frustrating, terrible experience. Hardware RAID really is super dead for a lot of reasons. Check out my other video on that. I've got more to say on that coming up, but software RAID, actually not terrible. But something that I would recommend that AMD pay a little bit more attention to in the workstation space. Because not everybody's going to buy CM7s for their big, giant, fast SSD. Is that a peak single-core clock speed of 5650 megahertz on a Threadripper? Yeah, I think it is. This is the 32-core Threadripper where it's going to boost a little higher. It's going to run a little warmer, depending on the cooler that you're using. Our NZXT is keeping it nice and cool. Tower cooler that I tested, running a little warmer. Just something to keep in mind. Maximum boost clock on that 32-core, 5650 megahertz. Pretty impressive that they're able to do that in that 350-watt power target without any overclocking or anything else. You actually do see those boosts for gaming and lightly threaded workloads. Interestingly, the Asus BIOS kind of gives away what each core is binned at the factory, at least on my particular part, anywhere from 5650 megahertz all the way down to like 5372. Doesn't seem to go in 15 megahertz increments exactly. I'll have to look more into that later, but anywhere from just shy of 5.4 gigahertz all the way up to 5650. And you will see 5650 on a couple of cores at a time. Definitely seems like one of those chiplets is binned for higher clock speeds than the other three. And the really amazing thing about this is the game performance. You don't really give up anything for game performance. 7950X levels of game performance, yeah, basically. But instead of 16 cores and 2 memory channels, you got 32 cores and 4 memory channels. It truly is a high-end desktop platform. Really, I think the only danger here is that if the 5000 series Threadripper Pro parts go on fire sale, then that could be a more compelling value than a 4-channel brand new Zen 4 platform. I mean, don't get me wrong, Zen 4 is a significant upgrade over Zen 3. It really is. But if you can get a 32 or a 64 core Threadripper Pro 5000 series for half MSRP, that could be a more compelling value than what we're looking at for this platform. We really don't have a small price jump from the 7950X and a fully kitted out system with 128 gigabytes of memory to our monster system as I have configured it for this video, which is also 128 gigabytes of memory, but with 32 cores or 64 cores, depending on which CPU loadout you want to go with. But if you're buying this for a CPU, are you really buying this just for a hobby and to have fun with at home? Or are you buying this because you make a little bit of money? And if you do make a little bit of money, maybe Threadripper Pro would be worth looking at. I'm certainly looking forward to looking at Threadripper Pro, but as far as engineering and resources and everything else, for performance and all of the technical details of this, AMD has really knocked it out of the park. They really have. I can't help but worry that this isn't going to get the fanfare that it deserves, because at this point, AMD is just a relentless execution machine, and that's what's expected. Everyone expects AMD to be a relentless execution machine, but this thing, it's no mercy. It really is no mercy. They have squeezed everything they can possibly squeeze out of Zen 4, and boy, they've squeezed a lot more out of Zen 4 than we saw on the Genoa server parts. Wow. Neat. I'm Wendell, this is Level 1. I'm signing out. You can find me in the Level 1 forums.